Welcome to Search and Study Tech. Today topic is identify the possible binary search trees for the identifier set do, while, if, else. Four keys is there. How many number of binary search trees are possible for these four keys? So what is the formula here? That is 2n cn by n plus 1. This is the formula. How many number of binary search trees are possible? 2n cn by n plus 1 number of binary search trees are possible. So n is the number of keys. Here it is a 4. So that is 2 into 4, 8 c4 by n plus 1, that is 4 plus 1, that is 5. So here it is 8 factorial by 8 minus 4, 4 factorial into 4 factorial by 5. You can expand this 8 factorial into 7 factorial into 6 factorial 8 into 7 into 6 into 5 into 4 factorial by, so can expand the 4 factorial here, 4 into 3 into 2 into 1 into 4 factorial. Now it is 5. 4 factorial cancel here. Here it is 4 into 2, 8. Here 3 2s are 6. So that is equal to 7 into 2 into 5 by 5. That is equal to 14. So how many number of binary search trees are possible for these number of keys? 4 keys. So 14 binary search trees are possible. So try to draw the binary search trees for these keys is, so first you can note down in alphabetical order. So do less than, else, less than, if, less than, while. So I am consider first binary search trees. Do is the root node, and here it is else. Right of the else is if, right of the if is while. Okay, this is the first diagram. Here it is. I am consider the second diagram. So do is the root node. So next one is if. Here it is left of the if is else. Here it is while. Now can see here it is do, here it is while, else, right of the else is if. So another diagram is do, here it is while, next if, left of the if is else. This is the another diagram. You can see here else is there, here if I am consider, here the while. In else is also, here also one more diagram is possible. Here you can see in a fifth diagram. So do, here it is else, here it is while, left of the while is if. So this is the another diagram possible. Like that we have to draw the all the diagrams. Now for example you can consider else is the root node. Here else is the root node. Here do is do, here it is if, here it is while. This is the another diagram. Like here it is sixth one. Now you can see the seventh one. Here it is else, here it is do, or while. Left of the while is if. This is the another diagram, seventh one. Like here it is, I am consider if is the root node, here it is else, and left of the else is do, here it is while. So ninth diagram is if is the root node, here it is do, right of the do is else, here it is while. So these are the diagrams. Now, so for example, while is the root node, while is the root node. So here it is if, left of the if is else, here left of the else is do. Next 11th one, 11th diagram, here it is. Here I am consider while is the root node. Now I am consider else one, else is there here. Right of the else is if, here it is do. This is the another diagram. Now I am consider while. This is the 12th diagram. I am consider while is the root node. Next you can see the do. Here right of the do is, I am consider if, left of the if is else. So like that here also in 13th diagram, while is the root node, while is the root node, like here the do is the left, and here it is else, here it is if. This is the another diagram, while. So here you can draw the one more diagram, like here while is there, while is the root node. So I am consider here it is if, if. Now you can see left of the if is do, here right of the do is else. You can see anywhere it can found if do else. So these are the 14 bind search trees are possible for the given number of keys. Thank you for watching this video. You can see here, you can do is the root node. Here the 5 bind search trees. Here it is else is the root node. Here the 2, 5 plus 2 7. Here it is if is the root node, it is 2, 7 plus 2 9. So while is the root node, here 10, 11, 12, 13, 14. So these are the 14 bind search trees are possible for these given keys. Thank you for watching this video.